we are going to study Science and Technology Part 1st. Chapter 3, Chemical Reactions and Equations. In the last video, we had already studied about chemical reactions. What rules are needed to write down the chemical reaction? How to balance the chemical equation? And on the basis of nature and the number of reactants, the chemical reactions are classified into 4 types: combination reaction, decomposition reaction, displacement reaction, and double displacement reaction. Now, let's recall activity number 3 from your textbook, in which you added potassium chromate K2CrO4 into the solution of barium sulfate BaSO4. What was the color of the precipitate formed? Well, color of the precipitate was yellow, and the name of the precipitate is barium chromate BaCrO4. Write down the balanced equation for this reaction. The balanced equation for this reaction is BaSO4 plus K2CrO4 gives BaCrO4 plus K2SO4. Will you call this reaction a displacement reaction or a double displacement reaction? Well, this reaction is double displacement reaction, as in this reaction the highly reactive barium displaces potassium from potassium chromate and forms the precipitate barium chromate as the product. Now, we had studied that heat is either given away or absorbed during various processes and reactions. So, accordingly, reactions are also classified into exothermic and endothermic reactions or processes. So, let's study about endothermic and exothermic processes. During physical changes, heat from outside is absorbed during the change. For example, melting of ice, dissolution of potassium nitrate in water. Therefore, these are endothermic processes. On the other hand, heat is given away during some physical changes. For example, formation of ice from water, dissolution of sodium hydroxide in water. Therefore, these are exothermic processes. Thus, we understand that when heat is absorbed, it is endothermic process, while when heat is given out, it is exothermic process. In the process of dilution of concentrated sulfuric acid with water, very large amount of heat is liberated. As a result, water gets evaporated instantly. If it is poured into the concentrated sulfuric acid, which may cause an accident. To avoid this, required amount of water is taken in a glass container, and small quantity of concentrated sulfuric acid at a time is added with this string while stirring. Therefore, only a small amount of heat is liberated at a time. Now, let's carry out endothermic and exothermic processes. Follow the procedure. Take 100 ml water in each of 2 two plastic bottles. Plastic being insulator of heat, the dissipation of heat can be prevented. Note the temperature of water in the bottles. Put 5 gram potassium nitrate KNO3 in the bottle and shake well. Note the temperature of the solution formed. Put 5 gram sodium hydroxide NaOH in the other bottle. Shake the bottle well. Note the temperature. In the first bottle, the process of dissolution of potassium nitrate took place, while in the second bottle, the process of dissolution of sodium hydroxide took place. As per your observation, which one is exothermic process and which one is endothermic process? Well, during the process of dissolution of KNO3 in water, heat from the surroundings is absorbed. Therefore, the temperature of the resulting solution is less. The process in which heat is absorbed from the outside is called endothermic process. When the solid NaOH is dissolved in water, heat is given out. Therefore, temperature increases. The process in which heat is given out are called exothermic processes. Now, let's understand what are endothermic and exothermic reactions. Till now we had studied that heat exchange takes place during chemical reactions. Accordingly, chemical reactions are classified into exothermic and endothermic reactions. During exothermic chemical reaction, heat is given away, while during endothermic chemical reactions, heat is absorbed from the surrounding. For example, CaCO3 plus heat gives CaO plus CO2. It is an example of endothermic reaction. While CaO plus H2O gives CaOH twice plus heat, which is an example of exothermic reaction. Rate of chemical reaction. Here are few processes. Let's take into account the time required for these processes and classify them into two groups, that is rapid process or slow process. First, cooking gas starts burning on ignition. Rapid process. Second, iron article undergoes rusting. Slow process. Third, erosion of rocks takes place to form soil. Slow process. Fourth, alcohol is formed on mixing yeast in glucose solution under proper condition. Slow process. Fifth, effervescence is formed on adding baking soda into test tube containing dilute acid. Rapid process. Sixth, a white precipitate is formed on adding dilute sulfuric acid to barium chloride solution. Rapid process. It can be seen from these examples that some reactions are completed in short time, that is occur rapidly, while some other require long time for completion, that is occur slowly. It means that the rate of different reactions is different. If we change the conditions required for the reaction, the same reaction may occur at different rate. For example, during winter, long time is required for setting milk into curd, while at the higher temperature during summer, the rate of setting of milk increases and the curd is formed early. Now, let us see the factors which decide the rate of chemical reaction. Factors affecting the rate of chemical reaction. First, nature of reactants. Let us see the reaction of metals. Aluminium, Al and zinc Zn with dilute hydrochloric acid. We know when metals react with hydrochloric acid, H2 gas, that is hydrogen gas, is liberated and water soluble salts of metals are formed. However, in this case, the reaction of aluminium metal takes place faster as compared to zinc metal. This happens because aluminium is more reactive than zinc. Therefore, the rate of reaction of aluminium with hydrochloric acid is higher than that of zinc. Thus, it is seen that the nature or reactivity of reactants influences the rate of chemical reaction. Second, size of particle of reactants. For this, let's take pieces and powder of Shahabad tile in equal weights in 2 test tubes. Add 10 ml dilute hydrochloric in each of these test tubes. Observe whether effervescence of CO2 is formed at faster or slower speed. Well, you will find that CO2 effervescence is formed slowly with the piece of Shahabad tile, while at a faster speed with the powder. This observation indicates that the rate of the reaction depends upon the size of the particle of the reactants taking place in the reaction. Smaller the size of the reactant particle, higher is the rate of the reaction. Third, concentration of the reactants. Let us consider the reaction of dilute and concentrated hydrochloric acid with CaCO3 powder. Dilute hydrochloric acid reacts slowly with CaCO3 and thereby CaCO3 disappears slowly and CO2 also liberates slowly. On the other hand, the reaction with concentrated hydrochloric acid takes place rapidly and CaCO3 disappears fast. Thus, concentrated acid reacts faster than dilute acid. This means that the rate of the reaction is proportional to the concentration of the reactant. That is, higher the concentration, faster the reaction. Fourth, temperature of the reaction. While studying decomposition reaction, we carried out decomposition of limestone. In that activity, the lime water does not turn milky before heating the limestone because of the zero rate of reaction. So, from that we learned that the rate of the reaction increases on increasing the temperature. Thus, higher the temperature, faster the reaction. Fifth, catalyst. On heating, potassium chlorate KClO3 decomposes slowly. 2 KClO3 on heating gives 2 KCl plus 3 O2. The rate of this reaction neither increases by reducing the particle size nor by increasing the reaction temperature. However, KClO3 decomposes rapidly in the presence of manganese dioxide MnO2 to liberate oxygen gas. No chemical change takes place in MnO2 in this reaction. Thus, MnO2 only acts as a supporting particle in this reaction and speeds up the reaction. Thus, the substance in whose presence the rate of a chemical reaction changes without causing any chemical change to it is called a catalyst. Similarly, the decomposition of hydrogen peroxide into water and oxygen takes place slowly at room temperature. However, the same reaction occurs at a faster rate on adding manganese dioxide MnO2 powder in it, where manganese dioxide acts as a catalyst. Catalyst may or may not be required during the reaction. It depends on that particular chemical reaction. But in the reaction in which catalyst is required, it plays a very important role to speeden up the process of that reaction. These were the 5 factors affecting the rate of change of the chemical reaction. Oxidation and reduction. Many types of substances gives reaction called oxidation and reduction. Let us learn more about these from the following reactions. First, 2 Mg plus O2 gives 2 MgO. C plus O2 gives CO2. Then MgH2 gives Mg plus H2. Then CH3CH3 gives CH2 double bond CH2 plus H2. In the reaction number 20 and 21, a reactant combines with oxygen, whereas in reaction 22 and 23, hydrogen gas is removed from the reactant. All these are the examples of oxidation reaction. A chemical reaction in which a reactant combines with oxygen or loses hydrogen to form the product is called oxidation reaction. Thus, when either oxygen is added to the reactant or hydrogen gas is released as the product, then the reaction will be termed as oxidation reaction. Some oxidation reactions are brought about by use of specific chemical substances. For example, ethyl alcohol CH3CH2OH in presence of nascent oxygen and K2CrO7 or H2SO4 gives CH3COOH, that is acetic acid. Here the acidic potassium dichromate makes oxygen available for the oxidation of the reactant ethyl alcohol. Such chemical substances which bring about an oxidation reaction by making oxygen available are called oxidants or oxidizing agent. That is, oxidizing agents are the substances which helps in the oxidation of the reactant. We have just now seen that the potassium permanganate is a chemical oxidant. Now have a look at the following reaction. 2 KMnO4 plus 10 FeSO4 plus 8 H2SO4 gives K2SO4 plus 2 MnSO4 plus 5 Fe2SO4 thrice plus 8 H2O. Here FeSO4 is transferred into FeSO4 thrice. Now let's see whether this conversion is an oxidation reaction or not. Since 2 FeSO4 gives Fe2SO4 thrice, the ionic reaction that takes place is Fe2 plus SO4 2 minus gives 2Fe3 plus 3 SO4 2 minus. The net change taking place in the above conversion is shown by the net ionic reaction as shown below. The net ionic reaction is Fe2 plus, that is ferrous, gives Fe3 plus, that is ferric. This net ionic reaction represents the oxidation brought by KMnO4. When ferric ion is formed from ferrous ion, the positive charge is increased by 1 unit. While this happens, the ferrous ion loses 1 electron. From this, we understand a new definition of oxidation reaction, which is oxidation means losing 1 or more electron. Thus, oxidation reaction can also be termed as losing of electrons of the reactant. This was about oxidation reaction. Now the chemical reactions which gain hydrogen are called reduction reactions. Similarly, the reaction in which reactants loses oxygen to form the product are also called as reduction reaction. The substance that brings about reduction is called a reductant or reducing agent. This means that oxidation reaction and reduction reaction are exactly opposite to each other. When hydrogen gas is passed over black copper oxide, a reddish colored layer of copper is formed, that is CuO plus H2 gives Cu plus H2O. Well, in this reaction, oxygen atom goes away from CuO, that is copper oxide, which means that the reduction of the copper oxide takes place, whereas hydrogen molecule takes up the oxygen atom and water is formed, meaning the oxidation of hydrogen takes place. Thus, here oxidation and reduction reaction occurs simultaneously. The reductant is oxidized by the oxidant and the oxidant is reduced by the reductant. Due to these characteristics of the reduction and oxidation reaction, a single term redox reaction is used in place of the two terms. Thus, redox reaction is the reaction in which oxidation and reduction reaction occurs simultaneously. Therefore, redox reaction is equal to reduction reaction plus oxidation reaction. Here are few examples of redox reaction. That is 2H2S plus SO2 gives 3S plus 2H2 and MnO2 plus 4HCl gives MnCl2 plus 2H2O plus Cl2. When the positive charge on an atom or an ion increases or the negative charge on them decreases, it is called oxidation. And when positive charge decreases or the negative charge increases, it is called reduction. Corrosion. To understand corrosion, let us perform activity. Follow the procedure. Place 4 test tubes on test tube stand. Take some boiled water in one test tube and put an oil layer on it. Take some salt water in the second test tube. Let there be only air in the third test tube. Take some anhydrous calcium chloride in the fourth test tube. Place a small iron nail in every test tube. Close the fourth test tube with a rubber cork. Let all the 4 test tubes remain unattended for few days. Take a look at figure 3.7 to study rusting. Well, we know that water and air are necessary for rusting. The rusting process takes place rapidly in presence of salt. We observe that a certain type of reddish colored solid layer collects on their metallic surface of nails. This layer is called rust. Its chemical formula is Fe2O3.XH2O. The rust on iron does not form by a simple reaction of oxygen with iron surface. The rust is formed by an electrochemical reaction. Different regions on the surface of iron become anode and cathode. First, Fe is oxidized to Fe2+ in the anode region. That is, Fe gives Fe2+ plus 2 electrons are released. Second, O2 is reduced to form water in the cathode region. O2 plus 4H plus 4 electrons gives 2H2O. When Fe2+ ions migrate from the anode region, they react with water and further get oxidized to form Fe3 plus ions. A reddish colored hydrated oxide is formed from Fe3 plus ions. It is called rust. It collects on the surface. Given by equation 2Fe3 plus 4H2O gives Fe2O3 dot H2O plus 6H plus. Due to various components of atmosphere, oxidation of metals takes place, consequently resulting in their damage. This is called corrosion. Iron rusts and a reddish color layer is collected on it. This is the corrosion of iron. Corrosion is a very serious problem. So to avoid this, various methods are used. Rancidity. When we use old leftover cooking oil for making foodstuff, it is found to have foul odor called rancidity. If food is cooked in such oil, its taste also changes. When oil or ghee is left aside for a long time, or fried food is left aside for a long time, it undergoes air oxidation and becomes rancid. Rancidity in the foodstuff cooked in oil or ghee is prevented by using antioxidants. The process of oxidation reaction of foodstuff can also be slowed down by storing it in the airtight container. This is the end of chapter 3. Do answer the questions from the exercise given in the textbook. If you have any doubt regarding this chapter, do ask in the comment section below. Do subscribe my channel and click the bell icon for notification. Do like and share the video. Thank you.